everybody, this is Miss Phoebus, and this is lesson 22 on slope-intercept form of linear equations. This is something that you probably are familiar with. We are going to look at a couple differences as far as real-world problems and things like that, stuff you might need a little bit of a refresher with, but we are going to be doing quite a bit of graphing. So it would be helpful if you have graph paper. If you don't have graph paper, then you are going to want to take a sheet of notebook paper, draw to the best of your ability, you might need to grab a ruler, an X and Y coordinate plane, and then try to space these guys out evenly so that you can do some graphing. So you do not need graph paper, it is not required. Now, if I see you next week, I'm going to be handing you a whole bunch of graph paper to help you out so that you can take it home and work on stuff like that at home. One of the other things I want to tell you before we get started is that in the homework I put some of the stuff for this lesson I accidentally put in for lesson 21. So if you felt confused about problems numbers 4, 5, and 6 and didn't contact me, I tried to, if you contacted me, I tried to send you an email back and let you know I put it in the wrong section. But if you felt confused about 4, 5, and 6, you might want to go back after this video and work on those problems. All right, so let's get into slope-intercept form of linear equations. So here's some vocabulary: linear function and slope-intercept form. We should know our linear functions by now. Our linear function is a function whose graph is a straight line. A linear function has one independent variable and one dependent variable. The independent variable is x, the dependent variable is y. So we should know linear functions by now. Slope-intercept form. Probably the only way that you graphed in middle school was in slope-intercept form. We have other forms that we're going to talk about later this week. But basically there's a slope and a y-intercept, and you're going to be able to plug those in and create an equation, y equals mx plus b. So I can graph linear functions written in any form by hand. So today is slope-intercept form. By hand in simple cases, or using technology for more complicated cases, and show and label intercepts of the graph. We're going to talk more about that in when we get to our standard form. I can construct a linear equation given a graph, a description of a relationship, or two input-output pairs, including reading these from a table. So we should be able to write as well as graph linear equations. And here are our standards: graph linear functions and show x-intercepts and y-intercepts symbolically, and look at using graphing by hand and by using technology, and then be able to write a linear function given different pieces of information. So here we go, slope-intercept form, y equals mx plus b. This is usually the answer I get when I ask the question, what is slope? I get all of this, but all of this is not slope. Only m is slope. So m is the slope of your line, b is the y-intercept, your starting point. And so when you graph your y-intercept first, and then you use your slope to get across the coordinate plane. Now when we graph, we do not graph dinky little short lines. We go all the way across the plane. I'm going to give you some helpful hints and things to think about as you're graphing. All right, so to graph, you're going to plot the y-intercept, and then you're going to use the slope to graph additional points. So here we go. Y equals 2/3 x minus 4. The piece that is in front of your x, this is your slope. This is your m. The piece that's at the end, the constant piece, this is your b, this is your y-intercept. Now we're going to pay attention to the sign. See that it's a minus 4, so that means that our y-intercept is at -4. So I'm going to go down from 0, 0, down 4 on the y-axis. This is not an x-intercept, this is a y-intercept. This is b, my y-intercept. All right, next we're going to get our slope on there. So we have to have a starting point. This is our starting point for our line. And our slope is 2/3. So rise over run, I'm going to go up 2 and right 3 and put another point. Now, some people will feel courageous and try to connect those two and be done, but not me. And this is not what I want you to do. I want you to graph to the best of your ability. So we're going to keep going up 2, right 3, up to right 3, until we run out of room on our graph paper. We're going to go down to left 3, down to left 3, down to left 3. We're going to go all the way across the coordinate plane. And the reason why is because later on when we're graphing two lines and we're seeing where do they intersect, we don't know where a second line would come through and intersect. So we want our line to go all the way across. So if you draw me short, dinky little lines, I'm going to be saying, why are you graphing me short, dinky little lines? I don't want short, dinky little lines. I want them to go all the way across the plane. I'm also going to be able to tell who's listening to me because I want arrowheads on both ends of my function because it continues on and on and on in both directions, from negative infinity to positive infinity. Okay, so you are going to start with your y-intercept, then you get your slope. To get additional points, you need to go up and to the right in this case, and then go back down and to the left. Okay, because negative 2 down 2 over negative 3 left 3 is the same as positive 2/3. So down 2 left 3 will keep you on that line. So I want all the way across the coordinate plane. Yes, I'm picky, but I'm picky in a good way because I love you. All right, so what we're going to do is we're going to check to see if these points are on a line. Now, I know that we just graphed this line, but we want to, and later on, you may not have the graph of a line, but have to check, is this point on the line? So we're going to check by plugging things in. We have an x value and a y value. Same thing over here. We have an x value and a y value. And what we want to do is we want to plug things in for x and for y and see if we get a true statement. True means that the point is on the line. False statement means the point isn't on the line. Okay, so we're just going to plug things in. So we've got y. Y is 4 equals 2/3 times x, which is 12, minus 4. 2/3 times 12 is 8. Does 4 equal 8 minus 4? 4 equals 4? Yes, it works. The point is on the line. All right, so I want you to check the other one. Now, just because the first one didn't work doesn't mean that this one's automatic. No, but, you know, you never can tell. Check this, pause the video, check this, see if it works. All right, so let's see. We should have plugged in a -5 for x, y, sorry. 2/3 times -15 minus 4. All right, so 2 times -15 is -30. -30 divided by 3 is -10. Is -5 equal to -14? It is not equal to, so this is not a point on the line. Now, I don't think that there's anything in the homework about this type of stuff, but I do think that there is a question on the test, and it should be pretty straightforward. So all you're doing is you're plugging in the x part of the point for x, the y point of the part in for y, and then you are going to figure out if you have a true statement or not. All right, so what are the slope and the y-intercept of each equation? So this goes back to questions 4, 5, and 6 I already talked about. You should know by now how to solve for y. If you do not, you need to be contacting me and we need to do a Google Meet and we need to talk about it. But we are going to solve for y, and once you have solved for y, you're looking for the slope is what is in front of x. In front of x. And then the y-intercept is the constant, the number piece, not with x. And then if there's no constant, it's an automatic 0. So let's look. We want m represents slope, b represents y-intercept. So my m, what's in front of my x? -2. Notice I am not writing x. X is not in front of x, just the number in front of x. Don't write x. It's wrong. All right, the y-intercept is the constant. See how it's a plus 18? It's a positive 18. All right, 18. So you're looking at y equals mx plus b. Tell me what m is. Tell me what b is. All right, so m equals b equals. M is the slope. What's in front of the x? 1/3. Now, where's the constant? There's nothing out here. I could put a plus 0. That would still be true. So my y-intercept is 0. So if there's nothing written, it's an automatic 0 for our y-intercept. Now, number 3, it's written out of order. And some of you, when you're solving for y, you write things out of order. That's okay, as long as you know what your slope and your y-intercept are from that. So remember, slope is the value that's hanging out in front of x. You want that sign with it, so this is a negative 1/2. And then the other piece is your y-intercept, a negative 6. So you're just going through, I think in 4, 5, and 6, you're just identifying slope. You may have to identify slope and y-intercept later, but that is what you're doing for this part. All right, so we're going to graph. You have to identify what the slope and the y-intercept is, and then use that to graph. So my slope is what's in front of my x, which is 2. My y-intercept is 5. We graph our y-intercept first on the y-axis. 5, positive 5, is right there. Do not graph it on the x. Had a couple people last year. They always graph the x-intercept. All right, we're going to go rise over run. So this is really 2 over 1. We're going to go up 2, right 1. I can't go up 2 and right 1 anymore, but that doesn't mean I can't go down 2, left 1 and still be on that line. Down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. All right, do not leave these as dots. I fussed at some of you in your homework. Feedback for not connecting the dots. We will connect the dots in these. They are not discrete functions, they are continuous functions. All the way across the coordinate plane, arrows on both ends, and we're done. All right, let's look at number 5. So we've got a y-intercept and a slope. Our slope is negative 3. Our y-intercept happens to also be negative 3. So we're going to be at negative 3. That means we go down 3 on the y-axis. And we've got a slope of negative 3. That means we're going to go down 3, right 1. Can't go down 3, right 1 anymore, so I'm going to go up 3, left 1, up 3, left 1, up 3, left 1. And then connect with the line, put arrows on both ends of the line. Now it's okay if your line has a little bit of a wiggle in it, because I'm really looking at the points. Are the points in the right spots? So if you are trying to do this without making points, it's going to be very, very hard for me to grade. And when it's very, very hard for me to grade, I tend to take off more points. So you draw points to get the points. It'll all work out in the end. Make sure your points are right, though. Don't just draw points everywhere. All right, let's try number 6. Our slope, what's in front of the x, is negative 1/3. Our y-intercept is 3, so we're going to start with our y-intercept of positive 3 on the y-axis, and then rise over run. So we're going to go down 1, right 3, because it's negative. Down 1, right 3, up 1, left 3, up 1, left 3. Hopefully, this is familiar. If it's not familiar and you're still having trouble, you need to contact me. Email, we can do a Google Meet. My lines aren't looking too great, but hopefully you get the idea what's going on. All right, let's look at 7. What's our slope? 7 over 2. What's our y-intercept? Negative 2. On the y-axis, we're going to put our y-intercept at negative 2 right there. We're going to go rise over run. 1, 2, 3, 4, 5, 6, 7 up, 2 to the right. I'm not going to be able to go up and to the right anymore. And 1, 2, 3, 4, 5, 6, 7. I could kind of do something like this, but it's a little sketchy. I'm going to focus more on these two. Any 2 points make a line, but the more points, the better. because you can still have a little bit of angling issues. As you can tell, I'm having some issues with this one. And the last one, more points the better. That's my motto. That's my take on this. All right, so we're going to write the equation of a line using slope-intercept form when you know one rate and a starting amount. So an airplane without fuel weighs 2,575 pounds. No fuel. This is my starting amount. Each gallon of gasoline added to the fuel tank weighs 6 pounds. That's a rate. As I am adding the fuel, it's increasing the weight 6 pounds per gallon of gas. So that is a rate. Write the equation to model this situation. So we're using slope-intercept form. Y equals mx plus b. Our rate is going to be our slope. Our starting amount is going to be our y-intercept. So if you can identify those, then you can plug them in. 6x for our slope is 6 pounds per gallon plus 2,575 pounds for our starting amount. There's our equation. So slope tells us the rate of change, 6 pounds per gallon of gas. The y-intercept tells us the starting amount, how much the plane weighs with 0 gallons of gasoline. So if you were asked to interpret the slope or the y-intercept, you are bringing those values back to what it means in the problem. All right, so we're going to use a table. We're going to write slope and y-intercept, and then we're going to figure out what the equation is. So the equation is always going to be, in this lesson, y equals mx plus b. That's what we're looking for. The y-intercept is always going to happen where the x value is 0. So you might want to make note of that. B happens when x is 0. And if you notice, I know when x is 0. So I know that my b value is 6. Now we're going to figure out slope. You can look at the rate of change. Like we did in the last video, you can do y2 minus y1 over x2 minus x1. That works as well. 4, we're adding 1. So our slope is -4 over 1, or -4. And so we're going to use that cleaned up fraction for our slope. Our y-intercept, we're going to create an equation. So y equals, the slope was -4x, and then my y-intercept was +6. And we can check it. So let's check by going to our calculator. And so we're going to go to y equals, clear out whatever's there, and we're going to type in -4x plus 6. Because we're writing equations, it would be nice to know if we did it right. So we're going to hit second table, and then we're going to go 0, 6 should be there. There's 0, 6, 4, -10, 4, -10, 5, -14. Let's check -2, 14. There it is. So hey, we wrote that equation correctly. Let's do another one. So remember that the b value, or starting value, or y value, our y-intercept value, that's when it has an x value of 0. So we found our b. Now let's figure out what we're doing. Looks like we're adding 8 here. We're adding 2 here. So my slope would be 8 over 2, which is 4. And now we're going to write our equation. Y equals 4x plus 3. Let's check it out. Let's look at the calculator. See, and you could plug them in by hand if you want to as well. And 4x plus 3. Plus 3. And then we're going to go to the table, and then we're going to compare. So I've got 0, 3, 2, 11, 4, 19, 6, 27, 8, 35. So I wrote it correctly. So it's always good to have a way to check. All right, now Using the slope and y-intercept, we're going to write the linear equation that models the graph. So we've got a video club, we're running videos, the amount of money spent. Ooh, is it discrete or continuous? Well, discrete means that it's just dots, no lines, so we're going to use discrete here. But we still can write an equation based off the same things. So let's look at what the slope is and what the y-intercept is. I can definitely see the y-intercept right here. So my b is 8. And what I want to do is I want to probably find another nice number because that seems to be pretty nice. This one looks pretty nice right here. That would be 8, 18. So I could count up 2, 4, 6, 8, 10, and then write 2, 4, 6, 8. And that would reduce to 5 over 4. So here's my equation. Y equals 5 over 4x plus 8. But let's look at the interpretation of each of these. So again, we're going to go back and we're going to look at our variables. So this is number of rentals, and this is the amount of money spent. So when we look at slope, we're looking at $5. That's the amount of money spent over 4 rentals. Or some of you might say, well, Miss Phoebus, isn't that the same as $1.25 per 1 rental? And I would say yes. The y-intercept is 8. So what does that mean? That means that you've rented 0 movies, and you are having to pay $8. So this is like an $8 fee to be in the club. And you could write an equation about that, or and you could write a sentence about that, where we're spending $8 to join the club and then $1.25 per rental thereafter. All right, let's look at number 11, the weight of a jar with marbles. So we've got numbers of marbles down here. We've got weight in grams. Is this discrete or continuous? Well, considering the last one was just dots, this is more than just dots. This is continuous. All right, so I'm going to pick some points. I'm going to pick some good points, like a point here, and this looks like a good point right here. And so what I'm going to do is I'm going to count rise or run. 20, 40, 60, and then I'm going to count run, go to the right, 10, 20. So 60 divided by 20 is 3. There is a slope of 3. And what that means is 3 marbles for every 1 gram of weight. So what we have is we have a jar of marbles. So this point right here, our y-intercept, is how much the jar weighs without any marbles in it. And unless we figure out what it is exactly, we're just going to have to estimate. So let me show you a trick on how to figure out. And we're going to use this again in a little bit. But we're going to plug in what we know so far. We know the slope is 3. We know a point. This is 10, 40. And we're going to plug in 10 for x and 40 for y. So we get 40 equals 30 plus b. So subtracting 30, 10 equals b, which I would have guessed it was closer to maybe 12. But according to the math, our y-intercept is going to be 10. So let's write an equation. Y equals 3x plus 10. Okay, now I'm going to erase this work, but we're going to interpret the slope. Now we've already looked at the slope. The slope is for every 3 marbles added, 1 gram of weight is or we've increased the weight 1 gram. My English is not really good right now. All right, and then for the 10, that's our slope. For the 10, the jar weighs 10 grams empty. Again, I don't like that. That doesn't look like 10, but it's not the best picture either. So it is what it is. So we're going to, given 2 points, write an equation that goes through those points. So this is kind of what I used in the last example. What we're going to do is we are going to figure out the slope, and then we're going to plug it in along with one of the points and be able to work and solve for our y-intercept. So the slope, we're going to do y2 minus y1 over x2 minus x1. So x1, y1, x2, y2, negative 1 minus 5 over 2 minus negative 2. You get negative 6 over 4, which is negative 3 over 2, or negative 1/2. Again, 1.5. Again, I want improper fractions. I think that that's going to be best. All right, doesn't matter which point we choose. Most of the time, I choose one where I have a positive x value, but a negative x value would work too. Sometimes there's a nicer point to choose. But y equals mx plus b. I'm going to plug in the negative 2 comma 5. So I'm going to have 5 equals negative 3 over 2 times negative 2. I did that so I get a positive. So the negative times the negative is a positive. The multiply by 2 and the divide by 2 cancel. So I end up with 5 equals 3 plus b. Subtract 3, so b is 2. So now I have my slope, I have my y-intercept. Let's write this, pull it all together. Y equals negative 3 over 2x plus 2. There's our equation. So a little bit of work, but we're able to figure out what it is. Let's try the next one. So y2 minus y1, gotta start with slope, x2 minus x1. So we're going to have 2 minus 12 over 7 minus 2, and negative 10 over 5, which is negative 2. And then it doesn't matter which one, I'm going to use this one. Y equals mx plus b. 12 equals negative 2 times 2 plus b. Negative 2 times 2 is negative 4. Add 4 to both sides, I get 16 equals b. So I've got my slope and my y-intercept. Y equals negative 2x plus 16. There's your equation. Alright, I'm going to have you guys work on these two. Pause the video, try to figure it out. Alright, so let's look at 15. So 9 minus 3 over negative 4 minus 2. 9 minus 3 is 6 over negative 6, which is negative 1. Y equals mx plus b. So it doesn't matter which point. Let's plug in 3 equals negative 1, that's my slope, times 2 plus b. 3 equals negative 2 plus b, add 2. So 5 equals b. So I've got my slope, my y-intercept. Let's go ahead and write our equation. So y equals, now you can write negative 1x. I usually write just negative x plus 5. There she is. How does it look? All right, let's do slope. 8 minus 4 over 5 minus 3. 8 minus 4 is 4. 5 minus 3 is 2. Slope of 2. Y equals mx plus b. So 4 equals 2. 4 equals 2 times 3 plus b. So if I subtract 6 on both sides, I get negative 2 equals b. So y equals 2x minus 2. There is our equation for our line that goes through those 2 points. So that is the end of this lesson. Just working in slope-intercept form, writing the equation for a couple different things, having a word problem, knowing how to find the y-intercept. If you're given 2 points and you are having difficulty figuring out the y-intercept, you can always solve for b by plugging in one of the values of the points. All right, that's it. I'll see you in the next video. Bye, guys.